Yavapai Broadcasting and the City of Cottonwood proudly present Inside Cottonwood, an inside look at the decisions and issues of the City of Cottonwood. Brought to you by Arizona Smile Designers.
According to the U.S. Department of Energy, an average American household used approximately 866 kilowatt hours of energy per month. That equates to about $70.68. For buildings the size of the recreation center, kilowatt usage is substantially higher. Good morning and welcome to Inside Cottonwood Parks and Recreation Edition. My name is Jason Little, Recreation Manager for the City of Cottonwood. And with me today I have Mr. Scott Mangerpan, the Project Manager/Engineer for the City of Cottonwood.
Morning.
Welcome, Scott. How are you?
Thank you.
Hey, Scott, you're new to the show and usually want to bring someone on, and especially someone who's accomplished as much as you have in life. I'd like you just to maybe give the audience a little history about where you come from, what you've done, and how you ended up working for the City of Cottonwood.
Oh, it's kind of a long, convoluted path. Actually, background is I'm an architect, graduated from U of A way back when. Over the years, spent a lot of time in California, Silicon Valley area. Most of my career there doing project management, actually, rather than design. And have worked on all sorts of projects, medical centers, data centers, residential, a little bit of everything. And we decided 20 years Silicon Valley, we'd had enough. And my wife and I decided to escape back to Arizona. We always thought we'd go back to Tucson, but Tucson's just gotten to be too big of a city. And we decided small town might be a little bit better. So we came through this area on a camping trip with the boys and said, we could make that work. And came out and ended up moving into Sedona. Kids went to high school there and have had a good time. Really enjoyed it. Came down to the city. I'd been doing some volunteer project management work for the Humane Society up in Sedona, and opportunity came up. They were looking for a project manager because it was project manager for public works. So I'm thinking, okay, well, roads and utilities, what do I know? But I figured project management's project management. And so it came down to the interview, and it turned out, no, they were doing a fairly large addition to the library and had this rec center project online. We were, I don't know, probably about 30% design, I think, when I came on board, and took that over to manage that process, and it's been busy ever since. That was almost 5 years ago.
Yeah, I hope we have some time to get into it later. I mean, you work on a menagerie of projects.
Oh, yeah.
And one that's near and dear to my heart and, of course, the people in the communities is the Recreation Center Solar Project. Mm-hmm. Like I said, I know as far as scale, you're working on probably a lot of larger projects right now, but primarily that's what we're here to discuss today. And for a novice like myself, I mean, until I started sitting in on some of these meetings with you, I had virtually no knowledge about solar. And I guess just to start off, if you could just kind of preface, what's the difference between solar electric and solar gas?
Well, we refer to it as solar thermal. And basically, that's the simpler of the two, in that you're just using the sun to heat up water. They've been doing it for decades, if not centuries, in one form or another. And this system that we're going to be putting at the rec center is a very basic, what they call it, flat panel system, where we pump water through these panels up on the roof. They collect the heat from the sun and return it back down into the mechanical room, where we transfer the heat to the water that's being circulated, either the circulated water for the large pool or for the hot tub, spa, or we also use it to heat the water that's going out to the showers and the sinks. The rec center uses a lot of gas, natural gas, for running the boilers to generate the hot water. And it's a good opportunity to try to offset some of that gas that we're using.
Now, a lot of people have a question. They raise the question to me, and I mean, I'm going to start referring them to you because you're the resident expert. But return on investment. Everyone asks me, why aren't we trying to reduce the electric bills? Why was this system chosen as opposed to the other system for the recreation center?
It's a good question, and it's one I keep going over my head, multiple times. Solar hot water, for the dollars you invest, as of right now, has a better rate of return in that you get more energy out of it for the dollar you invest than you do from, we call it photovoltaic or the electric solar panels. It's a little bit more efficient. You actually get more energy absorbed by the water than you do by the electric panels. And it's, in a normal office building situation or something like that, it probably wouldn't make sense. But in the rec center, we've got this huge pool, 60,000 gallons of water that we're constantly having to heat. You got a, whatever it is, 4,000 gallon hot tub, which we're trying to heat up to 103 or something like that. Mm-hmm. And then you've got, I forget the exact number, but something like 16 showers and 32 sinks where everyone's using hot water. So you've got a demand in that building that's not normal for a typical building. So that it's even a better argument to try to generate hot water and offset some of that use. The actual return on investment, that one we kind of discussed in our last meeting. It's hard to nail down because part of that calculation for return on investment is what's going to happen to utility costs in the future. And you can ask 10 different people and you'll get 10 different answers as far as where the price of gas is going. Right now it's at historic lows, fortunately. But where it goes from here, it's hard to predict. So when I went to the city council for approval, we gave them a range and said, the return's going to be here if the gas only inflates 2% per year. It could be here if gas goes up 6% per year. It's, in any case, even if it didn't inflate, the system will pay for itself before it wears out. So it isn't costing the city anything in the long run, and you're offsetting all that gas use. But we figure minimum, if you assume a 2% inflation, we've got a return, a payback in about 16 years. So that's probably the worst case scenario. If gas goes up higher, then it'll pay for itself just that much quicker. But it does pay for itself. So again, over the life of the system, it's not costing the city anything. And we are offsetting all that gas use.
And like you said, that's virtually an unknown as far as what gas is going to.
You could go into the internet and you'll get 20 different predictions.
Right.
It's hard to predict where it's going to go.
You mentioned that, and I was hoping you'd bring that up because you're right. It's depending on what source you're looking at.
Yeah, and it depends on the environmental groups, government. There's so many people that can affect that price right now, and part of it's just if the economy turns around and things pick up and people start using more of it, naturally the price will go up. So,
exactly.
We think it'll more than pay for itself over the life of the system.
I hope so. I know it will. Yeah. I mean, it's a no-brainer.
Yeah.
I mean, as one of our councilmen would say, with the city, there's a process. Whenever you choose a firm to design and build, something like this, what is that process, and who was selected to do the work?
All right. The process is we put together what we call an RFQ, request for quotation, or qualification, excuse me. And we advertise it in the local paper over a couple of weeks and it gets picked up by all sorts of groups. The contractors associations are really good about picking up stuff like that. And we got, let's see if I can remember now, 7 firms submitted statements of qualifications. And of those 7, we went through it with a review committee and narrowed it down to 4 to interview. 4 firms that we felt were qualified to do this type of a project. And of the 4 we interviewed, we narrowed it down to the one firm we thought was the best fit. And it's a firm called MCore Services. They're actually a large mechanical contractor, but they've kind of gotten into this little niche of the solar thermal. Which is exactly what we're looking for. And they've actually done the student rec center down at the U of A. with a much larger system, because that's a bigger building. The demand is greater there. And they've even taken it another step where they use the solar system on that building to provide air conditioning, which gets into this whole more complicated system of the absorption chillers and how that works. And we're not doing that. We're just trying to generate hot water to offset the gas that we're using to create it. But they were more than qualified to do that. We selected them. We then sit down with them and negotiate a fee, which is basically their markup on what the project's going to cost. And then went into design, got the design done. You've seen the drawings for it, and now we've just gotten the approval on the final price for the system. Again, it's a negotiated process, and then we'll go from there. Right now, we're in the process of getting the materials ordered, finalizing a little bit of the design details as far as the electrical and stuff like that, and hopefully, if everything goes on schedule, we could be looking at the system up and running by the end of November. I think that's a little ambitious, but that's what we're shooting for right now.
I really find that whole chiller thing fascinating. I mean, the technology behind it, I mean, it's pretty amazing.
And actually, it's really an old technology. In the way, if you've ever had a refrigerator in an RV or a camper or something that runs off propane, which seems counterintuitive, you're generating cooling with heat, but it does work, and the absorption chiller that they put in at the rec center down there works the same way. In fact, it's the waste heat, the leftover heat that they have after generating all the air conditioning down there that they use to heat the pool. But we're not getting that that complicated on ours. We don't need to right at this point.
Well, I think that's a good place to stop for our first break. And when we come back, we'll continue discussing Recreation Center solar that hopefully will be installed by the end of November.
Meet the team at Arizona Smile Designers, offering complete, comprehensive, restorative, and aesthetic dentistry. Dr. Vergara and Dr. Lord specialize in dental health, implants, and cosmetic dental procedures. Expert staff and state-of-the-art equipment bring forth the most from your smile. Dr. Ripplinger conveniently comes to Arizona Smile Designers for oral surgery and complicated procedures. Visit Arizona Smile Designers at 350 South Willard in Cottonwood. Insurance and new patients are welcome. Call 634-8610.
Good morning and welcome back to Inside Cottonwood Parks and Recreation Edition. Jason Little here with Scott Mangerpan with the City of Cottonwood. When we went to break, we were talking about the Recreation Center solar project and the firm that was selected to do it. I guess what I would like to start this second segment with, Scott, is what makes this project unique in and of itself?
Well, I know you sent me that question, and I thought about it, and it's not really a unique project. This is something that's been done. I mean, I can remember one of the first projects I worked on back in California was in a building that had a solar thermal system on its roof from the late 70s. Now, the technology's gotten a whole lot better as far as the quality of the materials, reliability of the system, like that. But they've been doing solar hot water for a long time, so it's not really all that unique a system. There's certain things with the rec center that'll, make it specific to the rec center, but it's really a very simple system. I mean, you pump water through this loop that goes to the solar panels up on the roof, comes down, goes through a heat exchanger where it transfers the heat to the loops that are already there for either the showers or for the hot tub or for the pool. There's literally 4 pumps, and that's the only moving parts in the entire system. It's very basic in that there is a sensor that determines either the system is encountering freezing temperatures up on the roof, which occasionally we get, and it'll turn the pumps off and all the water drains off the roof down into a storage tank in the mechanical room. Or in the middle of the summer where everything's working great and we finally reach the point where we don't have no demand for the hot water, it works the same way. It turns the pump off, the water drains back down into the storage tank, and that's as complicated as it gets. The most difficult part is going to be installing the panels on the roof to keep them from blowing off in a strong wind, which we we'll be bolting into the structure of the rec center itself, and making sure the pipes flow so that when the pump turns off, it does drain down, because we want to make sure we don't have any water left on the roof when the system turns off. So in case, with those few nights we do get freezing temperatures, that we don't leave anything up on the roof to break.
Scott, you've been here for a long time, and before we go further with this conversation, I would like to kind of just go off in a different direction here. You've been involved with this building, and you have a great deal of familiarity with the building. Mm-hmm. What other energy savings designs were put into the recreation center that the public might not see or might not know about?
Again, when we were building it, we went through a whole energy study, try to identify what made sense and what didn't make sense. We weren't going to just jump in and do everything if the numbers didn't pencil out, as they say. We went through the whole process and narrowed it down to the basic, constructability type things that we could do. Added extra insulation on the roof, almost double what's required by code. Extra insulation in the walls. What we call low E windows to help reflect the heat away from the windows in the summertime, and it actually helps a little bit to hold the heat in the wintertime. Trying to remember what else we looked at. I had actually some notes on that. But it was just more construction type details that we built into it from an energy efficiency point of view. The main active system we dealt with was the daylighting, is what technically call it. Basically, it consists of a whole bunch of skylights throughout the facility. If you ever, when people come in, they can look up and you'll see a ton of skylights in that building. It allows daylighting. It basically allows us to turn off a lot of the lights during the daytime and rely strictly on the sunlight coming through the skylights. You can, you get some through the windows, but a lot of the building it's so big, perimeter windows just don't work. So the skylights were put in specifically for that. And then there are controls that will control the built-in lighting to dim them down, to turn some off when there's enough light coming in from the outside. Very similar to what you see in a typical Walmart. If you go into a Walmart and you look up, that thing is full of skylights, and they've learned over the years that it's a great way to save energy during the day. It's kind of a weird feeling if you're in there on a cloudy day and a cloud goes by and all of a sudden the building gets really dark, because they're relying on these skylights, and it works great at the rec center. That's probably the fanciest technical system we have from an energy conservation, until we put the hot water system on the roof. But those are what made sense. We went through this whole study. In fact, we even got a rebate from APS for doing the study to try to identify possible options. But there were a lot of things that we initially looked at that the paybacks were, 30, 40, in some cases 75 years out.
Oh, wow.
Well, those don't make sense doing.
Yeah.
But anything that had a decent return, we did, and it seems to be working out. It's still not a cheap building to run. You know that.
Oh, yes.
And probably the next option we could look at would be adding PV solar somewhere down the line. But it's not a cheap proposition. And again, the hot water makes more sense to do right now. Down the line, look at PV.
Now, when you talk about this project, how many panels are we looking at putting up on the roof?
As of right now, and because we may tweak it a little once we get into it, we're looking at 96 panels up on the roof. And they're about 4 foot wide and 10 feet high, the actual panel itself. Now, you mount them at a low angle, so they'll only be 5 or 6 feet above the roof, depending on how we have to mount them to allow for the water to drain. And trying to think, we did, in the process of building the rec center, we did beef up the roof structure on the roof above the pool, because that's what we've assumed would be the place you would want to put these, and that's where we're going to put most of them. Will be on that roof, and with another 25 or so on the roof of the actual mechanical room itself, to give us the total of 96. And that seems to be the proper amount so that we're not over-generating and wasting money on the purchasing of the panels, but generating as much as we could possibly use. Where you're still tweaking the numbers a little bit, so the panel number may change a little bit up or down, just depending on how the final numbers come out. But there's going to be a lot of them up there. You may not see them from the ground. There's enough parapets around the roofs up there, and we'll be mounting them at a fairly low angle that they may not be all that visible from the ground. Whether that's a good thing or not depends on how you feel about the solar. Exactly. I like keeping them hidden just because it's less of an attractive nuisance.
Exactly.
But there's nothing wrong with trying to show off every once in a while too. Yep. If we got them, we want to take advantage of it. But that's about it. I mean, it's a very basic, simple system.
That's great. Panel integrity, technology advancements. What are these panels? What do they consist of?
Yeah, well, that's the one I mentioned before that they've been around for a long time, but the technology's gotten better. Mostly, it's in the construction of the panels, in that they're using aluminum frames, tempered glass on the front. The quality control and the construction, the sealing of the joints, the actual panel that you pump the water through is a copper panel, copper pipe connected by copper panels, and all that's the quality control at the factory is a whole lot better than it used to be. So chances of anything failing on a panel are pretty slim. I mean, even the tempered glass that sits on top of the panels, it's rated to withstand 1-inch hail.
Oh, wow.
Hitting it.
Yeah.
In fact, I was at a meeting the other day, and the guy talked about that at the UL lab in San Jose, near where I used to live, they actually test these panels by firing 1-inch diameter ice balls at it through a cannon at 150 miles an hour.
That's a job I'd want.
He says it's interesting to go watch. You got to bring hearing protection, but it's interesting that they even bother to try to test it that way. I mean, 1-inch hail should pretty much cover us for most things around here.
Absolutely.
But that was the old technology. They didn't hold up all that well because of the quality of the construction, the quality of the glass. And they would fail, and then people wouldn't bother to fix them. They come with a 10-year warranty. Everyone tells you to expect a 25 to 30-year life out of them. The pumps, again, that's the one moving part. They come with a 5-year warranty. Chances are, in the lifespan of the system for 30 years, somewhere in the 15 to 20-year range, we'll have to replace the pumps. But you're talking 3 small pumps and one horsepower pump. Okay. It's not a major investment. It's just, you figure it into your return on investment, but it's not a big deal.
So just send that bill up to you.
Yeah.
We're talking Recreation Center Solar Project. We're going to go to our second break. When we come back, I got a few more questions for Scott just to wrap things up.
Meet the team at Arizona Smile Designers, offering complete comprehensive, restorative, and aesthetic dentistry. Dr. Vergara and Dr. Lord specialize in dental health, implants, and cosmetic dental procedures. Expert staff and state-of-the-art equipment bring forth the most from your smile. Dr. Ripplinger conveniently comes to Arizona Smile Designers for oral surgery and complicated procedures. Visit Arizona Smile Designers at 350 South Willard in Cottonwood. Insurance and new patients are welcome. Call 634-8610.
Thousands of fires across the United States are caused by careless people. Hi, I'm Fire Marshal Rick Contreras with the Cottonwood Fire Department. The major threat of human-caused fires are from burning debris that get out of control or improperly extinguished or unattended campfires. Remember that fireworks have no place on our wild lands. Become part of the solution. Learn more about proper fire safety by contacting your local fire department.
Welcome back to Inside Cottonwood Parks and Recreation Edition, the show that keeps you in the know of everything happening here in your community. With me today, I have Scott Mangerpan, the project manager for the City of Cottonwood, and we're talking about the Recreation Center Solar Project. Scott, when we went to break, we were talking about firing 150-mile-an-hour ice balls at solar panels, and I guess I'd like to stay on that train of thought there, and let's talk about winds. What can these panels sustain? Because I know we do get some winds.
Well, I mean, the bare minimum by building code is anything you put on a building has to take, and I'm not sure the exact time frame, but 90-mile-an-hour winds for like a 5-minute gust. Well, that's a lot of load to put on these panels, and that's what we designed for. So the biggest thing with anything you put on the roof of a building is not so much the weight of the equipment on the building itself, it's trying to keep the wind from tearing it off the building. So all the mounting structure and all the anchorage on these panels will be really designed around keeping them from blowing off the roof. And as we mentioned, we're working with the roofing contractor that put the roof on the building to begin with and is maintaining the warranty on the roof. And he'll be in charge of any penetrations we do to the roof to bolt these panels down. As I mentioned before, we did beef up the structure so that it can withstand having stuff attached to it and pulling up on it in the case of the wind, or the dead load in the case of just the weight of the equipment. So it's, it'll be designed to handle that. And the panels themselves, they're not the weak link. They're more than strong enough to handle that kind of wind. It's the anchorage of it to the building is where you really have to be careful and make sure you detail it right.
Ever since the article came out in the Verde Independent about this being approved by council, I probably get 2 to 3 inquiries a week about when the project's going to start, duration of the project.
Well, as I mentioned, we're targeting end November. The panels, they're already under order. In fact, they may already be here in the state. I'm not sure the exact delivery date. For the most part, it's getting the details finalized for the anchorage and then getting up on the roof, doing the anchorage through the roof membrane, getting that all sealed back up so that everybody's happy with that so we don't have a problem with roof leaks. But you'll physically see stuff probably showing up in about 3 weeks. And then the installation itself really only takes a few weeks. Then it'll be firing the system up and working out the bugs, getting the controls working. So that's why we're shooting for the end of November to have it all done.
Do you foresee this impeding or interrupting any building operations?
Not from the public's point of view, because we're not doing anything that'll impact any of the public spaces. Really, the only work we're doing inside the building is in the mechanical room. So, we will be working with your maintenance staff to make sure that's coordinated. The biggest thing you might see would be out in the staff parking lot. We may have to block it off for a couple of days, bring a crane in to throw all the panels and all the mounting equipment and everything up on the roof. Once that stuff's delivered up there, it's just a matter of, hoisting it around and getting it in place up there. I would imagine most of the public won't even realize we're doing any work. Like I said, it'll be more of a disruption for the staff, only in that we'll tie up the parking lot for a while, a portion of it. And we'll be working with your maintenance people to make sure they understand what's going on and trying to stay out of their way while they're trying to make the building operate on a normal, schedule and everything.
I can give them a general answer. A lot of questions center around the outdoor pool. They ask me, why aren't you guys putting solar on the outdoor pool when it's 4 times as large as the indoor pool? Can you just briefly touch upon why we selected the Recreation Center?
Yeah, we did actually start out with the concept that we were going to do 2 systems, one in the rec center and one at the outdoor pool. We got into the numbers and started running the calculations on the outdoor pool and realized that with the short season that you have over there, it's a very expensive system to sit up on the roof of the pool house over there to only be used for 4 or 5 months out of the year. We went through the numbers and realized that for the same amount of money, we could upsize the system at the rec center and get a better return for your money there. And it's strictly a function of how the outdoor pool is used, and the rec center is year-round. We've got a demand for showers and heat, and even heating the pool and the hot tub. That's a constant demand. That's really where you want to target the production for the solar thermal system, is where you have that constant demand. The outdoor pool, yeah, when you're firing it up in the spring or in the late fall, early fall really, you use a lot of gas, but then it's shut down. And then in the summertime, with the sun hitting it, we use very little gas out there in the middle of the summer. So it's not an ideal situation for solar thermal. If we were trying to keep it open year round or something like that, you might want to argue adding a system out there. But until that happens, it's just not worth doing.
Well, Scott, I can't thank you enough for being on the show today. I guess in the last 30 seconds we have or so, can you talk about any other projects that you're considering for solar in the city? I mean, are you looking at any other buildings?
Yeah, we're looking at a couple of opportunities. In fact, I was at the seminar over in Prescott Valley Friday, going over some opportunities there. We did do a PV system that was funded through a federal grant at the airport. Fortunately, we had a structure there, a shade structure there we were able to put on there. Some of the targets we might look at, there's several buildings throughout the city that have large electric bills, Rec Center being one of them. It's a matter of figuring out the economies of it. Things are changing. APS rebates have gone way down. I mean, where you could have gotten a $40,000 rebate a couple of years ago, you'd be lucky to get a $4,000 rebate.
Wow.
So the economies are changing. So many people are doing it that the rebates are backing off, and it's just changing the economy of doing it. We'll look at some things based on some of the conversations I had with some of the solar people Friday, but we've got to look at it on an individual building basis to see whether what's practical and what's worth doing. So we'll target other buildings and see.
That's great. Well, once again, Scott, thank you for being on the show, and audience, thank you for tuning in. If you guys have any other additional questions out there as it pertains to this project, please feel free to call my office at 639-3200. If I can't answer your questions, I'll turn you over to the expert here, Scott Mangerpan. Once again, thank you for tuning in.